Alrighty, everyone. Great. So today is a very exciting day because we're now starting to transition to ReactJS. So today we'll be doing an introductory lecture for the next hour, and then we'll be doing a workshop later this afternoon to get familiar with Catbook and implementing Catbook using React. So you've heard us mention React in the past couple of days. And now we're going to dive deeper into understanding React. And so before we get started, if you ever have any questions or get lost or anything, right, we have the question stock, weblab.to/questions. And then we also have the help queue, which is weblab.to/queue. And you can just get help from a staff member. Throughout this lecture, there's going to be three big terms that we're going to introduce that you're going to be hearing a lot. And I'll kind of emphasize when we're talking about each term. But the goal is that it's really important for you just to get like a basic grasp of where it is. And we'll continue iterating on these concepts and these practices later today in a workshop, and then tomorrow as well with more lectures and workshops. So if you're still unclear, that's fine. You can always ask on the question doc, but I'll kind of emphasize when we get to there. So let's kind of recap what we've been doing for the past couple of days. So on Monday, we started by introducing HTML and working with different semantic tags like divs and spans and sections and IMG, images is IMG, right? All of these cool tags that run in HTML, right? And they have the carrots to have the tags, right? And then we also talked about CSS. So we could create, CSS is a style sheet language that helped us design our elements. And we can create margin styles, font size changes, color changes, things like that. And then yesterday we were talking about JavaScript, right? And we're talking about bringing functionality. We introduced this idea of a callback function, right? And we'll be having more practice of that, right? And so if you remember this analogy from yesterday, we were really talking about how a website brings together HTML, CSS, and JavaScript, where HTML is like the bones that like brings structure to your site. And then the CSS is like the skin that is kind of the design and look of your website. And then JavaScript is the muscle, right? It provides functionality to your site. However, as we saw yesterday, right, when we were trying to directly manipulate HTML using JavaScript, it becomes a lot of work, right? And it's quite an outdated process and not something that is very commonly seen among web developers today, right? And the reason is because there's a lot of third-party JavaScript libraries that make it easier for us to build websites. And these libraries are in charge of, we kind of operate at a higher level, and it's in charge of converting our code at a higher level into lower level HTML code. And so that's exactly what React is. React is a JavaScript library that's used for building user interfaces. So React isn't really a new coding language, but it builds off JavaScript, and it allows us to build websites in a more broken down way, right? So first, let's just kind of take a look at some real world examples, right? You've all heard of Facebook, right? We've been showing it in a couple examples. Shannon just mentioned Airbnb, Instagram, Discord, New York Times, Code Academy, Instacart, all of these websites here, right? They all have different purposes, right? Netflix is for entertainment, Spotify is for music, Uber is for transportation, right? But there's one thing that binds them all together. There's one commonality among all of these websites, and it's that they all use ReactJS. They're all built in React. And so React, it's a very popular front-end library. It was actually developed by Facebook in 2013. And it's open source, meaning that other engineers, including yourself, can build more libraries on top of React. And there's another lecture I think Noah's going to give on libraries. But just know that there's a lot of existing libraries built in React that help you build cool functionalities. So why do we use React, right? Well, first of all, it's modular, right? So it allows us to treat our website as like a bunch of pieces and smaller broken down chunks that can exist independently, but they can come together to form a website like a puzzle, right? So, and we'll kind of show like how it gets broken down, right? React is also a pretty fast language. It's pretty lightweight for us to develop. We don't have to require directly manipulating the HTML document for every single change we need. If you're from yesterday, we would do like document.getElement by ID, and then we would do like append child to add items to a list, like all of that, right? But this allows us to operate at a little bit of a higher level, so we don't have to do a lot of that manual labor. And lastly is that React is very readable. So when we start looking at the code later, you'll see that what we visually see on Chrome or on your Firefox window, whatever you see on a website, can be very easily translated and recognized into different React components, right? And we'll talk about what React components are exactly. So if you remember from Tommy's lecture on Monday, when we talked about HTML, we were talking about divs and these elements as boxes, right? We're drawing red boxes around the site, right? Well, ReactJS follows a very similar structure, right? Except that we call these boxes React components, right? So you'll hear a React a lot throughout the course of this class, and it's really at the heart of React. Or components, you'll hear about components a lot, and that's at the heart of React. So this is the first big term, and we'll define it a little bit more. So component, right? So a React component lets us break down a chunk of our UI into a reusable and independent piece of code. And it can be represented as like a piece of HTML code. It can also be comprised of other React components or a mix of both, right? And the one key thing about it is that React components can receive and maintain their own information, right? So now we're kind of combining HTML and JavaScript together, right? And a component, when it gets rendered into our website, it gets converted into HTML code. So so we're kind of building it like as mini segments of our HTML page. And so here is this example right here. Let's look at this nav bar right on Facebook, right? We can treat this entire nav bar as one component, right? And so when we're trying to think of like, how can we break down this component into smaller chunks, maybe take like 10 to 15 seconds and feel free to put in the Zoom chat or speak up, like, what are like some pieces that you think we can identify, right, in our nav bar? And if you don't know, that's really okay. Just give it like 10, 15 seconds. Kind of just like at a high level, like what are some parts to the nav bar that make up the nav bar? See, search bar, buttons, icons, direct message, Nico. Thanks, Yassine. Notification profiling, search bar, buttons to different pages, button to key down. Cool, wow, looks like you guys are doing well. So yeah, so you guys are pretty much on it, right? So one way that we can break this down is at a high level, right? We can think of the nav bar as like 3 different sections. All right, oh, I'm back, there we go. So we have 3 different sections. So we have this left section that has someone to the icon in the search bar. And then we have this middle section that has all the buttons, right, to the different navigation links. And then we have the right section that has like the profile information, the messenger chat, the notifications, right? So like that's one way that like we as a web developer can say, all right, my task is to build the search bar component, right? And your teammate will say, all right, my task is to build the middle navigation button component. And the last teammate says, all right, I'm in charge of building the right component, right? So rather than you all working on one index.html file, you can all create and maintain your own independent components. And then the parent component, the larger navbar component, will bring them together like different pieces to a puzzle. So that's one cool thing about the design. That's when we talk about breaking down into a chunk, right? And so we can continue to expand this idea recursively, right? So we can think of, if you remember from HTML, we were kind of talking about boxes inside boxes, right? These nested boxes. Well, in ReactJS, we actually call them child components. And so child components really help us understand what structure we use, right? So here in these blue boxes, these are all child components to the middle component in the red, right? And the reason why we call them, why we can use components is that these 5 icons they all represent navigation links, right? They all have the same structure, right? But they might display a different icon based on what type of icon we tell it to display, and they might have a different color based on what color we tell it to display, right? But these components are just structural elements that exist that we can reuse. And in fact, if you can, you're encouraged to reuse React components. And that's kind of the one thing that makes this design a little bit easier, is that you can focus on only building one template component and then passing in information. And so we can expand that idea to the entire app. We can consider our entire website as just one component called app that represents multiple child components, right? And so we looked at one example with the nav bar, but now we can look at it to look at the entire website, right? So React apps are just components of components, right? So let's do another exercise, right? This is the Instagram web page. It's not as common as the Facebook web page, but it's really well designed. So maybe like take another 15 seconds, and what are some higher level components that we might be able to break down our app into, right? And think if you can identify like 3 big components that just make up the structure of our site, right? I see feed, stories box, stories feed, suggestions, good, stories, story suggestions, nav bar, menus, nav bar, feed, user thing. Yeah, so so at a higher level, you guys are doing pretty well at this. We can see that, I'll show it with the boxes, right? We can see that we have the nav bar at the top, right? So before we were looking at just the nav bar example, but now we're looking at the entire app, and the nav bar is one child component of our app. We also have the feed on the left, and then we have this sidebar on the right. And you can continue to break down this exercise, right? The sidebar is made up of a profile link, the stories scroll view, and then the suggestions, right? So you can continue to like understand how components are broken down. And that's like something really nice about this, right? But how do we actually populate them, right? So components only tell us where certain things should be. It doesn't really tell us what content should exist, right? So my sidebar will probably look different from Shannon's sidebar, even though they're both considered a sidebar component, right? And so that's just kind of like the first overview of components, is that they are really just more structural components that can render based on what information we give them to. And so before we move on, are there any quick questions on like a component or how to recognize them? Component is like a term that you're going to hear a lot in this class. And so it's important you kind of understand its purpose. There's no set rule on how big or how small a component can be. You know, one unique feature about components is that you can localize all the functionality and information, right, to a certain component. And we'll kind of talk about how that works, right? But yeah, so, and if you have any questions that come up later, you can put it on the question doc. And that's on the question, weblab.to/questions. So with a bunch of components, we can React actually uses a component tree structure to organize our different components, right? Remember, we were talking about how each component is like a piece to a puzzle. And when we bring them together to create the puzzle, that's what our website is, right? So you don't really need to know anything about how trees understand from like a computer science point. All you need to know is that the component tree structure helps us organize our components in relation to one another. And often this structure looks very similar to the visual UI that is seen on the website. And so as we said, here's a sample of our component tree. The website can be considered one component at the highest level. We call that app. So our root component is app. And app can contain multiple child components, right? So in this case, we can see that the 3 high-level components, like one level underneath app, is the nav bar and the feed and the sidebar, right? And then feed is another component, right? Feed is a component that can hold a scrollable list of posts, right? And each post is its own component, right? And a post can have a story, right? And so in this case, we're referencing story as like the content, right? Not what you think of like the 24-hour Instagram story. It's just like the content of a post. And then the comment, right? A comment is just another component that can be associated with a post, right? And so the indentations in this component tree can help us, can help indicate like what level the component is in the component tree. And it helps us understand the relationships, right, between components. So a parent to a child component, right? So app is the parent component of navbar, feed, and sidebar, right? And it's all relative, right? But why do we want to use a component tree, right? Well, it turns out that this component tree actually comes super helpful when we're understanding how to pass information, right? Especially from parent components to child components, right? And this diagram here uses arrows to indicate the direction at which information is passed down. And notice right now, we're only talking about downward information. We'll talk about later this week on how you can pass information back or around, right? But for now, we're only talking about information going downwards, right? So how exactly do we handle this information? There's actually two key concepts of handling information. And so this is the second big term of the lecture. So the first one, we talked about components, which were kind of the structural elements that we use in React to build our website. Big term number two is props. So it's probably new to you. You'll hear a lot about it and debugging and in the rest of the class, right? Props is just input information that comes from a parent component to a child component, right? So let's look at this diagram again. So props are, they're just like little pieces of information that we can pass down, right? And it's a one-way relationship, so we call it parent to child, right? Think of it as like a family tree. Our website's like a tree, right? It goes family to child. And we also say that props are immutable. So if you haven't had that term before, all it means is that it's read-only. So we can access whatever variable is in props, but if we try to reassign it, it's not going to change it in the parent. So that's when we say, so if you're ever trying to like, you're in navbar, right? And you hit log out and you want to tell the entire app that you're logged out. You can't just do this.props. Like logged in user is equal to no, because you're reassigning something that is immutable. It's read only, so you can't reassign it. And so we'll talk about later this week on how you can communicate upwards, right? But for now, just know that the props are like your inputs that come into a component. And so what do they look like? Well, what can be passed down? You can pass down a JavaScript object, Boolean variables, IDs, text, numbers, functions, all the JavaScript primitive types, right? Pretty much anything and everything can be a prop. You can also pass down other components. This is a rare case, and usually there's a better way that you can structure your React code, so that way maybe the child component already has the component. But there are some occasions where you might want to pass it in as a prop, or sometimes it's easier or whatever. But just know that this is a rare case, but it is possible to do. It's just not as common as other props that we use. So that's pretty much the overview to props. We'll have more practice when we start looking at the code and in the workshop later. But just remember at a high level that these are the inputs to a component. They are passed down from a higher level component to a lower level component, and you can't change them, right? And one quick thing as well, you can pass down props the entire way down, right? You can have some prop at nav, and you can continue to pass it down into feed, and feed can continue to pass it down into post, and continue to pass it down into story. It's not limited to just one level, right? But usually you want to structure it so that way whatever component needs the information will generate that information, right? So like the app doesn't need to know every single comment on a post, right? But maybe the post component can generate the comments that go with that post, right? That's just one thing to keep in mind when you're working with props. So that's big word number two. So first one we talked about was components, just kind of the structural elements of React. And then we talked about props, which is the input information we pass down. And then the next big word that we're going to introduce is state. And this is going to be the last one for today, the third big term for today's state. State is a little bit different from props, but it's another way of handling information. State is private information that is maintained and updated by a singular component. So it's pretty much private and it's specific to one component. No parent component can access the state of a child component. That's something that's like really important. And state is pretty common when you're trying to handle input changes of a component, right? So this example here, right? Let's say you have a form and you're asking your user, what do you like, right? And you have a list of checkboxes that say, I have a bike, I have a car, I have a boat, right? And they can click which one that they like, right? And each individual checkbox can be associated with the state variable. So checked one might be the Boolean status for the first checkbox item. Checked two can be for the second one. Checked three can be for the third one, right? And we can maintain them in an object, right? So checked one is equal to false, checked two is true, and checked three is also true. And so let's say this is inside like a login form or some form component, right? But that component is inside our app component, right? Well, remember how we're saying that state is private and cannot be accessed by any other component, right? So the app component cannot access the state of a checkbox, right? So that's something that's really important about state, is that you want to be careful about where you want to define variables, because if you ever have two components or more than multiple components that need the same variable, you would want to store the shared data in the common ancestor, right? Sometimes it's state, sometimes it can be something a little higher level, like in the feed example has all the posts, right? But that's just something to keep in mind. Components also have initial states. So whenever you create a React component, it always has an initial state, right? And for this example, maybe we want to initialize the state to all be false, right? So it's none of the checkbox, and usually that's pretty standard, right? When you see a form, like nothing's already filled in, right? When you fill in a Google form, everything is pretty much empty, and it's up to you to enter in your answers to a Google form, right? So the initial state is like an empty string or a false Boolean variable, things like that, right? And so we said that components can manage their own state, but they can also maintain their own state. So we can write functions that update the state of a component. And we'll talk about that later, right? But yeah, are there any quick questions on state? And so we've talked about props and state. Both of them are ways that we can manage information in our web app. But they're a little bit different in terms of when we use them, right? So a common phrase that we use is that you want to make states stay. So they're stayed in a component, they stay in a component, but you can make props pass. Usually it's downwards. So you pass information downwards to a lower level component. So let's kind of recap what we've talked about so far. We introduced this idea of a component. So a component lets you break down like a chunk or piece of your UI into a reusable and independent piece of code. So it's like little pieces of the puzzle that we can bring together. And it can be represented as HTML code, or a component can be made up of other components. As we saw, app is made up of like the navbar component. It's also made up of the feed component. It also has the sidebar component, right? And it can be made up of both. We talked about how components can receive information using props. So props are the input, and they can also maintain their own information, their own state, pretty much like the state of the component. And React uses the component tree structure to organize our components and to pass information. And this component tree structure is very similar to what we saw on a Google side stuff, or on our Google Chrome tab, sorry. So yeah, and so each component takes in props as inputs, and props always go downwards, and then it manages its own state, which is like private information. And it's private to its own component. So if you ever like working in your own component, you have access to state. You don't have, it's not like an encrypted variable, but any component outside of it cannot access it. And then, yeah. So here's a question: do we ever need to pass information upwards? Yeah, Nick said he answered on the question. Short answer is yes, you can. You use functions for that, specifically callback functions. We're not going to teach it today because this is more introductory to React, but you'll have more practice with it tomorrow and Friday and next week as well. But yes, it does happen, and it's pretty common. So if you're so confused on how all these work, right? Well, let's take an analogy, right? Let's look at a hotel. So after taking Web Lab, this IAP, you're actually hired by a hotel to build a dashboard on a website, right? And luckily, the Web Lab staff has just taught you everything and anything you need to know about building a fully functional website in React. And so there's a couple key features about this hotel. There are 3 different room types. The first one is a single room that has 1 bed. Then we have a double room that has 2 beds. And lastly, we have a family room that has multiple beds and rooms to fit more people, right? And your goal is to create a dashboard that indicates how many rooms of each type there are and how many of them are vacant, meaning no one's currently sleeping in them, and we can assign any guest that walks in the door to that room. So here are the 3 room types again. And so luckily your teammate was also hired by this hotel, and your teammate also took web lab, and they learned how to build a wireframe from Shannon's wireframing lecture. And they already built the UI. So here is what the UI will look like. It consists of a dashboard, which is this gray box here. And it has a bunch of room for it has a bunch of different rooms that each have a picture with them to indicate what type of room we have. And it has a room number to indicate where in the hotel this room is, right? And one key feature about this UI is that it actually changes color. The room picture will change color to indicate that someone is currently in that room. It's currently occupied. So if it's a darker color, that means someone is in that room, and the hotel staff should not tell someone to go to that room. So with this UI ready, it's up to you to figure out how you want to build this app. And so for purposes of this analogy, we're not focusing on like the JavaScript functions, on maintaining this website. We're still just talking about how do we structure our components and how do we pass information between them. So don't worry about doing any JavaScript functionality right now. So the first thing we want to ask ourselves is what does our componentry look like, right? What are some components that we can create that we can use, right? So I'll go back and I'll leave this UI up for maybe like 30 seconds. So start thinking about what are some reusable components that currently exist in our app that we can reuse. And if you want to put in the Zoom chat or speak up, you're welcome to. I'll give you like 30 seconds to think about it. So the room, see room component, make a template for each room type. Yep, you're all on the right track. Yeah, so someone actually suggested we could make a template for each room type, right? That's a great choice. I will even expand that further, and I'll say you can just make a singular room component and just pass in information to that room component to tell it what type it is, right? So remember that React component is just like a structural element. It's just a template, right? It's not dictated by what content it has. So when we pass in information, it will, the look of the component is dependent on what information it has. And you can make static components, but then you're kind of remaking components and kind of defeats the purpose of this idea of reusability and modularity in React. So it still could work, but you can continue to expand that to just one room component. But either work, right? So let's look at our componentry here. So remember, we have the app at the root, that's our website. And then we have a dashboard. And our dashboard will contain all of the room components, right? So let's go back to the UI. And so just take a second to see we have a dashboard, and the dashboard has a bunch of child components that have rooms, right? And so if we go back to the UI, we can see that that component tree structure is very similar to like what the look of our app looks like, right? We have the dashboard component that has a bunch of child components that are the room components, right? And so that's when we're starting to talk about how React is a very readable language, that we can convert what components we have into an actual visual structure of our app. So the room component is what we want to focus on. So let's talk about information management. So we talked about props, right? And props is kind of this read-only input information, right? So we have 3 pieces of information. We have room type, room number, room type, and vacancy status. So kind of a multiple choice question, which of these pieces of information do you think should be a prop? Meaning that the parent component is passing this information into the room component. I'll give you like 15 seconds for this. Yeah, see, people think it's vacancy status. Someone says number and type. Yeah. So the correct answer here is yeah, someone said room number and type, vacancy status. Oh, someone's getting ahead. So the correct answer here is the room number and the room type. Remember that the prop component is read-only, right? So we're not updating, like, unless like the hotel's getting a remodel and we have to redefine numbers and change rooms, right? But that's not really common, right? So this information is kind of predefined. It might exist on a database, or it's just some fixed information that we pass into each instance of a room component, right? So each room will have a room number and it will have a room type. And it could be a single room, a double room, or a family room, right? And we might be thinking, why is vacancy status not a prop, right? Well, when someone checks in or checks out, we need to update the status of it, right? And we remember that props are read-only, they're immutable. So we can't change them, but if we create a state variable called like vacancy or something, then we can maintain it that way and continue to update it without running into any issues. So here's what the component tree looks like. So the dashboard component will have a list of all the rooms, and for each item in our list, it'll create a room component and it'll pass in props to each one. So it'll pass in a room number prop, which is an integer, and it'll pass in a room type prop, which is a string. So that's kind of like the structure of props here. And so, yeah, so this is just kind of the structure of room components. Right now, so we're only talking about passing information downwards. The key thing about props is that we also know it's independent, right? So this first room component cannot access it cannot it's like input, right? So it can't change its own props, right? So if I'm a room, right, and I'm assigned to room 100, right, I can't say, oh, I'm going to actually change myself to 101 because it's a prop variable, it's read-only, it's something that's predefined at a higher level component. And in this case, it is the dashboard component. Yeah, someone asked, is props short? Yeah, it's basically like the properties, right? We just call it props, or a prop variable, a prop value. That's kind of pretty common across React. And so now we were talking about state, so I think we already talked about this, right? Now we're trying to think of like private, localized, and independent information that cannot be accessed or changed by another component. And one thing that this word private might be a little bit confusing. It's private to any component outside of it, right? If I'm my component, right? If I'm my own room component, I can check and access my state variables, and I can actually change what I look like based on what variable I have, right? That's the beauty about React, is that React components will react based on the information that it has. So if the state changes, right, it can be like, oh, I'm no longer vacant, right? So when we're thinking about what state do we want to track, in this case, we want to track the vacancy status. And we want to check if someone is living there. And remember from the UI at the beginning, if someone is living in a room, then the image gets shaded in, right? And then when someone checks out, it's now in full color. So that's kind of how we manage props and state. And state can continue to update. So when someone checks out, we'll say, is vacant is equal to false, right? So we can represent props and state as different variables for our components. So now we have this new variable called is vacant, and it's a Boolean variable. So it'll be true when no one is in the room and it's clean and we can assign someone to that room, and it'll be false when someone is living in the room. And so we can understand the props and state of each component, excuse me, as JavaScript objects, right? We were talking about objects yesterday and how they behave very similar to Python dictionaries, if you've used those before, or hash maps in Java. But props here is just a JavaScript object that we can access. Props.room number is an integer value to indicate the room number, and props.room type is a string value to indicate what type of room we have. And then state is vacant is just a Boolean variable that we can access, we can read from, and we can also update it. We can write to it, right? We can switch it between true and false. So when we bring it back together to the component tree, we have the hotel app, and this should be app, but it's like the hotel app, right? And it has a dashboard, and the dashboard has a room component that takes in two prop variables, a room number and a room type, and it has a state, which tells us if it's vacant or not. So that's kind of like another way to think about props and state and components. We'll have more practice with this later today when we do a workshop, when we'll continue to talk more about these ideas. But these are kind of the big three terms that you should try to get out of this lecture is what components are. It's like the structural elements of our app. Props is like the input information that's defined by our parent component, send it to its child. And then state, which is just some value or variable that we can access and maintain and update. And so as I said earlier, we want to make states stay, and we want to make props pass. And usually we pass it downwards. So now we're going to move on into like talking about how we write JavaScript components, right? So we've been talking about these concepts of component tree structure, prop, state, right? But what do they look like in actual code? So let's kind of just go through a couple of code snippets to get you familiar with it. So JSX is a syntax extension that basically, at a higher level, it just allows us to write HTML code, HTML-like code snippets in JavaScript files. And we'll kind of show you how that is. Normally, you can't write like HTML code, like divs with like the tags, the self-enclosing tags in JavaScript, right? Because it's a different language, it doesn't know how to compile it, right? But JSX is a syntax extension that allows us to do it. So we'll kind of show you how that works. So this is a component. This is that comment component. Remember, we talked about like the feed and the post has like a story and a component and a comment, right? And we represent components as classes in JavaScript, right? So you might, this is kind of similar to how we've seen classes in Python, or if you've done other class-oriented programming, right? But they're a little bit different, right? They are JavaScript classes, but we call them like components. They're actually React components, but we just build them in the class structure. So anytime you write a component file, you need to import React and component from the React library, right? And so if you, what this notation does is importing the React exported package, and then it's also exporting like a smaller package called component that we use, right? And so the class has two functions that we're going to start talking about. We're going to talk about a couple more later this week. But the first method we're going to talk about is constructor, right? And constructor is basically what helps us initialize our app, right? This will run when we first declare and initialize our app. It's very similar to like init in Python, or the constructor if you coded in Java before. It takes in props. So remember, props are like the inputs that come into a component. But because this is a React component, we actually initialize these components a little bit differently, right? So normally in Python, you would do like C1 is equal to new comment, right? Or in Java, you might do comment C1 equals new comment, right? That's actually not how we initialize React components. In fact, that's like pretty much no one does that for React development. It might still work, but like I would avoid it because that's just not the way that you declare them. And so this is like a big no-no. Instead, we use the self-enclosing syntax tag, right? Notice we don't need new. We can just declare it as let C1 equals with the self-enclosing tag, and then we put whatever the name of the component is, right? So here we have the comment component. And so now we can reference C1 as just like this is an instance of our comment component, right? So that's just something, that's how we like kind of initialize and reference it. And this is when we were talking about writing HTML-like code inside of a JavaScript file. This is running inside a JavaScript file. So if we go back to our comment class, let's first talk about constructor, right? So constructor and render are these predefined functions that actually come from the component superclass. And so, we actually call these lifecycle methods. Kind of already said. We call them lifecycle methods because these functions get executed on a certain and predefined lifetime or life cycle, right? So they're called lifecycle methods. And we'll talk about more later this week. But just the two for today are constructor and render. Constructor initializes it, right? So let's take a look at what constructor, an implemented version of constructor looks like. So here we have constructor. And so a couple of notes here is that props is those inputs that we pass down. It's just a parent component. So there's props. And we call on super props, which calls on the superclass of component to initialize props. And this basically helps us recognize that this class is actually a component. It's not just a regular JavaScript class. And then this is where we initialize state, right? Remember we were talking about state as an object, right? So we initialize the state, and states have initial values. So we can initialize the state in constructor, right? So here for a comment, we'll just say, if I've liked a comment, we're gonna say the initial state of it is just false, right? And it just represents if the comment's been liked or not. So that is constructor. Usually you wanna limit how much code you put inside constructor. There's a lot of other methods that you can use to do more operations, but usually your constructor, it only runs once and it's at the beginning when you initially declare your component. And it's really much more used for like variable declaration. So that's constructor. Then render is the next lifecycle method that we'll cover. So render expects a return type of HTML-like code. So that's why we have to include a return, right? Because otherwise render just will run, but it's not returning anything to the compiler. So it won't actually show up in our website because you're not returning what the output should be. You can do a lot of JavaScript operations inside render before you hit return, but for now we're only returning some predefined content, right? So we'll start off by returning a div element. So this is kind of similar to what we saw in the first 2 days with HTML. We have a div and it has an ID called cool comment, and it has a class name that has comment.text, right? Just to note is that if you remember what the CSS classes for in HTML, we use an attribute called class. But class is a reserved variable in React, so it's called class name to access the same CSS classes, right? So if you're ever like, rendering a component, but the link is but the styles aren't showing up, make sure you're using class name. That's super important when you're working with React, right? So class name is one key note, and we'll continue to remind you about this. But that's just, you'll probably use class name a lot, and we'll use it in the workshop. And then what we can do is we can actually, inside the div component, we want to return the content of what our prop is, right? So let's say we can access this by calling this.props.content. And there's a couple things going on here. First, we're using this, right? Notice how we use the this.state, this.props. That's because we're referencing like this instance of our component, right? So this.state represents the state of like this version of the common component. Same thing with props, right? And then we can also introduce, and then we can access it using like the dot, right? Because it's a JavaScript object. So dot content or state dot is like, this dot state dot is like, right? And here's another cool thing about React, and this is what I really enjoy. Do you see these little brackets here, right? In line 20, they're actually blue, right? And so what's actually going on here is that this is actually a mini HTML environment, right? So these parentheses in line 18 and line 22 basically open up an HTML environment, right? Right now we're using them in return, but you can use them pretty much anywhere else to like declare a variable, right? So now we're in this like HTML environment, right? But let's say you want to access a JavaScript variable, right? You can actually use the brackets again to go back to basically open up a mini JavaScript environment inside your HTML environment. So that's what's going on here, right? That's why they're blue. That's why they're not the white brackets that we've seen in the other lines. So this.props.content allows us to access the variable. If we don't have the bracket, then it's just going to render the string like as a string on your website, this.props.content. But when we put the brackets around it, now it's saying, hey, we're in JavaScript. Let's access the variable from our JavaScript file that's this.state.content. And it will be able to access that, assuming that props.content is passed in and defined. So that's just two things. As we said, lifecycle methods run on a timeline. So for now, we're just going to manage this chart. It will continue to update it more. But first, we know that constructor gets called, and it'll immediately jump into render. And so these are kind of when we talk about these predefined cycle timelines of our React apps. So let's do a quick sanity check. We've been talking about it a lot. So React components use constructor to access props and initialize state. So this.state and this.props, these are JavaScript objects that we can access. And then render is what we use to return HTML-like code. So we have to make sure we're always returning something. You can return null. That's another option. If you don't want to return anything, you can return null. But you need to return something so that way the compiler knows, okay, when I build this component, this is what it should look like, right? And then we were talking about these cool parentheses that create a mini HTML environment. And then if we're inside the HTML environment, we can use a set of brackets to go create a mini JavaScript environment, right? And this can happen because we have that JSX syntax extension at the beginning, right? And that's already included for us. You don't have to worry about setting it up. But that's just one thing to note about that's really cool about React that you can't do in normal JavaScript files. And then lastly, we're talking about class name. So React uses a class name as an attribute for CSS classes, but in CS and HTML, we use class. So we've kind of talked about what the constructor does, what render does, what accessing props like. So we've covered constructor, render, and props, right? Now let's talk about the final kind of trifecta, or whatever the fourth item is, state, right? So let's talk about accessing state. So remember we said state is just a variable that's contained inside our component. It can be, it's private to any other component, but inside your component, you can access it and you can maintain it. So it's initialized in the constructor as an object. So we do this.state is equal to just a set of brackets. This is just saying that there's nothing there. In the comment class example, we used isLiked and we initialized it to false. They're private and they're managed by each individual component, meaning no other component, can access or update it. And we're going to introduce this cool term called conditional rendering. We're not going to do a lot with it today, but I'll just show you a quick example about it. And Kai and Claire are going to go over it later this week when we do a little bit more React. But conditional rendering basically allows us to render certain elements based on the state of a given component, right? Someone asked a question yesterday on the question doc that was like, do we need to why do we need to keep doing document inner HTML and updating it, right, for a given input, right? Something has changed, right? And in theory, what we can do is we can just say render this component if it works, and if not, render this other component, or do something else, right? Show something else, right? And that's pretty much the heart of React, right? Is that React will render based on, and will react to any changes it gets, and it'll render based on the current state of the component. So this allows us to really only have one component, and we don't need to have we don't need to write a lot of different versions of a component and switch them out. We can actually maintain it inside one component. So let's take an example of the render function. So it's the same thing, but now we want to introduce a like button, right? And so let's say we want to show a like button if the state of a component for isLiked is equal to true. So in line 19, let like button, we're just initializing a variable. We're not, or we're declaring it, but we're not initializing it to any value. And then in line, we're doing this if else logic statement here to basically check if it's liked. We want to set the value equal to a like button component, assume it's predefined for us. And if it's not, we're going to set it to null. And by setting it to null, we're just saying don't show anything, right? And then in line 29, we will say, we will use the mini brackets to access the JavaScript variable, and we'll put like button, right? Notice that we don't need to do this dot like button because we're declaring the variable inside render. And this is pretty common. You'll have a lot of logic inside render because render is basically going to be doing all the checks on like, should I show this or not, right? And you could do multiple checks in one render function. That's kind of what's going on right here. But we'll continue to kind of iterate this right now because there's a little bit of an easier way to write this code. A little bit cleaner, a little bit nicer, a little bit faster. And so there's the like button, right? Notice that regardless if it has a value that's associated with the like button component, or if it's equal to null, we still want to have it inside our return statement, right? We're only returning once. That's something that's super key about React. We're not doing like if this, return that, if else, or else return this. And we can basically assign it to null. So when it compiles, it'll be, all right, I'll add whatever my content is. And if liked is false, I'll put null here. It's going to replace this with null. So it's not really going to show anything, right? But if it is like, it'll show something, right? So that's kind of like something that works out. And so this logic right here, we can simplify it, right? And so we're going to introduce this idea of a ternary operator. And a ternary operator basically says you can assign a variable like let result. And so result is our variable. And it has this cool syntax that basically says we check our condition, and then there's a question mark. And then the first value is what we assign result to if this condition is true. And the second value is if it's false. Right? And so we use a question mark. So this is basically saying, I'm checking condition. What is condition with a question mark? If it's true, do this value. And if it's false, do the second value. And this is much nicer. And you'll learn more about this. It's okay if this is your first time seeing it. I'll show you what it looks like in code. So what we can do is we can combine the like button assignment into one line of code. Before it was like 5 lines of code. Now we can do, we're checking the state if it's liked, and you can do multiple checks in this Boolean check, right? But here we're only doing one. So we're checking the state of is liked, and if it's true, we're gonna set it equal to like button, and if it's false, we're gonna set it to null, right? So now, this is a much cleaner way to do it. You can still do it the old way before in this logic, right? That still works, but if you kind of want to know how to write it in a cleaner way, you can do like button here, right? So this is a much cleaner way. And I'll say that you can even clean this up even more. As we said earlier, the brackets represent inside our return statement, the mini blue brackets, basically create a JavaScript environment, right? So you can actually put this code in here in line 24, right? So we don't even have to assign it. So it'll look something like this, right? Where our render statement is just checking if it's liked, and it'll basically replace this line of code with like button, and it'll replace it with null based on the like check. So this is a little bit more advanced, but it's just like one way that we can access state, and now our component will render differently based on our certain state. And that's kind of what we talked about doing React. So we'll have more practice with this tomorrow, but this is just something to know when we're doing it in one line. Yeah, can fit in one line. So we've talked about accessing state. The last thing, or one of the last two things that we want to do is now updating state. So remember, state can be maintained and updated by a component. So the component will actually automatically rerun render whenever the state of a component is updated, right? So that's one thing to keep in mind. So how do we update state, right? So let's say we define this function called like comment, that when we click on the comment, it'll execute this function, and we want to indicate that we've liked the button, or we've liked the comment, and we want to show the like button. So, this .state.isLike equals true. Does anyone think this will work? And if you have no idea, that is perfectly okay. Short answer is that this does not work. And so updating state is really unique to React, that it's not just some JavaScript object. Well, it is a JavaScript object, but there's a lot more underlying work that happens with state. And so that's why updating a variable it's more than just that, right? because we also have to re-render this component, right? We have to re-render any child component, right? So there's a lot of stuff that we have to do. And notice that we're not like doing this.state.is like true, and then we're not writing render, right? We're not calling the render function. That's because React will automatically do that for us, but we have to, but it'll only do it if we update the state correctly, right? So you might think, okay, well, can we just reassign what state is, right? Is this another option, right? Turns out this also does not work. We cannot do this dot state is equal to, like we cannot reassign what state is, right? That's how we define it in our constructor, but whenever we're updating it, that's not how we do it, right? So you're probably getting mad at me and you're like, Nico, why are you showing us this? Like none of this works, right? So what the point of this is to show you that updating state is a very particular process and something that we need to be very careful on how we do. So how to update state correctly. So it turns out React has this cool function called this.setState. And so whenever we update the state of a component, as we said, there's a lot that's going on, right? Thanks, Jose. There's a lot more going on that you'll want to update than just updating the simple property of a JavaScript object, right? It turns out this.state is actually creating a request. It's saying like, hey, React, hey, JavaScript, I want you to change this variable, but I'm going to send you a lot of other requests in the behind the scenes that you need to do. You need to re-render this component. You need to re-render any child component. You need to re-render any child component of that child component, right? And if we're passing down props to any child components with the state variable, it has to re-render, right? So let's think about when you log out of an app, right? Usually a piece of information, like if you're logged in, is held at the very top because it basically affects your entire website, right? And what happens when you log out? Usually you lose access to all of you log out of Gmail, right? And you lose access to your inbox, right? It only shows you the login page. Well, that's expected. And what's happening is that we're actually updating the state of our app at the very highest level, and it's re-rendering every single component. It's really only re-rendering like our main component, right? Because it's basically saying, don't show inbox, right? Show only login. But so, think of set state as it's just sending a request to do a lot of operations, but after it, the state will be updated, right? And because it's a request, and I think Noah's going to talk about this at the end of the day, we don't know when that request is going to be finished. So we call that an asynchronous request, right? Don't need to worry about it for today. Just know that if you do this.setState and then you try to access the state variable like in the line right after it, we're not guaranteed to know if it's been updated or not, right? Because we don't know if it only needs to render one component or if it needs to render a bunch of child components. And so this is the proper way of doing it. I think Kai and Claire are going to show more examples on how to do it where you can check the current state, right? But this is what we want to do. For when we like the comment, this.setState is liked as true, right? And so we're basically saying this is what the new state should be, right? And notice that we only have one variable in this component, right? When we get into talking about more variables, we'll talk about how you can how to selectively update certain variables. But for now, you don't need to worry about that. We're only focusing on one comment, but just know that it can expand into that. So we run this.set state is like true. And then when that runs, we will basically re-render the component. And then if we want to attach that function, so let's say when we click on the comment component, we can use this onClick attribute, right? We were talking about onClick events yesterday when we were talking about JavaScript. OnClick basically says, when I click on this div element, execute this function, right? And it's executing this callback function that is this.LikeComment, which is what we defined in the previous slide. So we define LikeComment as this arrow function. It doesn't really take in any parameters, but when we call on it, this.setState is liked as true. And we can associate it with whenever we click on this div element, we want that function to execute. So at the end of the day, this is what our comment, I think I misspelled it. This is what our comment component looks like. We have our constructor that called super on props to basically convert this JavaScript class into a React component. We initialize a state, this.state as a JavaScript object. We created a function called LikeComment that will update the state of isLiked, and it actually does this.setState of isLiked is true. And then we have our render function. So render will return, it always has to return HTML-like code. Remember that the parentheses allow us to create an HTML environment, and then the brackets inside the HTML environment allow us to access JavaScript variables. And then to review this ternary operator, this is basically saying this dot state that is liked. It's checking this condition with this question mark. So it's like, is it liked? And if it's true, if it is liked, return the like button. And if it's not, just return null. So notice how we're not even using return at all. And then, one, I don't think I mentioned this. Kind of hiding it. There's at the bottom, you always have to export your component. So it says export default comment. Your React, so notice how we're importing and exporting, right? We're importing and exporting whatever we tell it to, right? So here we're saying export comment, right? And then any other component can do import comment, right? And it will create a component class, but it doesn't have to worry about doing comment, that instance of comment dot like comment, right? Because everything is handled inside this component. So that's what we talk about when we're saying it's modular. We only have to worry about like this comment does not really care about what's in the post or what's in the story or what's in the navbar, right? It's very modular, right? And it's very readable, right? This component, we can see it has the content. It has some styling to it. It has an ID. It tells us what happens when we click on it. And then this will just tell us, if liked is true, then show the like button. And if not, we'll return null. Just going back to that lifecycle timeline, constructor runs when we first, initialize our component. Then render gets called. And then anytime we change state, and we have to make sure we're using set state, it'll render, re-render, automatically re-render this component. And it'll also make sure it handles render for any child component. So we don't really have to worry about that. And yeah, I think, so we've talked about a lot. This is kind of pretty much the end of this lecture. So we've talked about why we use ReactJS. It's much more modern, it's faster, it's more modular, it's a more modern way of web development. We've introduced the three big terms. Components are the structural elements of React. And we talked about how we can use a component tree structure to organize them and pass in information. Props was the second big term. That's like the data that's input. And then state is the last one, which is the private information that is maintained inside a component. We looked at what writing JavaScript components look like using the lifecycle methods of constructor and render. And we talked about accessing props and state using this dot props and this dot state. And then we can update state using this dot set state. So we've done a lot. I think we're going to break for lunch soon. So we'll be back at 3 p.m. Eastern or 3:05, one of the times. If you have any questions, you're still stuck, definitely ask on the questions doc. Maybe add yourself to the queue. We can help you out. These slides are on the website right now. So if you miss something, it's weblab.mit.edu. And then when we start at the workshop, we're going to do a workshop after this. We are going to make sure you have VS Code open with Caphook React, because we're going to continue to iterate that. If you're stuck on Git, on Caphook, on VS Code, definitely add yourself to the queue.